Today we're going to be deriving the cosine law, which is another helpful formula that helps us figure out the angles or the sides of a triangle that isn't necessarily a right-angled triangle. So, I'll remind you how I labeled this triangle. Capital letters equal the angles, so capital A is an angle, capital B is an angle, capital C is also an angle. Lowercase letters equal the sides, so lowercase c is all of this, lowercase a is all of this, and lowercase b is all of this. And matching letters are the opposite side or angle. So uppercase B is across from B, uppercase A is across from lowercase a, and lowercase c is across from C. So that's how I labeled my triangle. So because this is not a right angle triangle, we can't use the tools that we're traditionally familiar with, such as the sine, cosine, tangent functions or the Pythagorean Theorem. But if we split this triangle like this, call this height h, now we have two right angle triangles, and it looks like something we're more familiar with. But this does pose a problem. The area from here to here, what is that? If B, like I said earlier, was all of this, then what's the area from here to here? Well, we don't know what that is, so we're going to call it x. And if we call this x, therefore we must call the area from here to here b minus x. And this makes sense because b minus x plus x is equal to b. So if I combine this area from all of this plus the area from here to here, then I'm just going to get the original b value from here all the way to here. So now that we have defined our triangle, let's start deriving the formula. So let's use the Pythagorean Theorem and see what happens. The Pythagorean Theorem is a squared plus b squared equals c squared. So let's choose one side, a squared to be b minus x squared plus another side, so h squared plus h squared equals the hypotenuse squared. So the hypotenuse squared would be this, all this, equals c squared. Alright, so let's do it again for the second triangle. One side, which is x, so x squared plus h squared, which is another side, h squared, equals a squared, which is the hypotenuse. This is the longest side of this right angle triangle, so it is a squared. Alright, so let's isolate for h on both sides and see what happens. If we subtract both sides by b minus x squared, we're going to get h squared equals to c squared minus b minus x squared. Okay, and on the right side, let's subtract both sides by x squared. So we get h squared is equal to a squared minus x squared. And now you have to make another key observation, that if c squared minus b minus x squared is equal to h squared, and a squared minus x squared is equal to h squared, that means both of them are equivalent, which means you get to use the equal sign on both of these. So let's write it. C squared minus b minus x squared is equal to a squared minus x squared. That's cool. Alright, so since we have a binomial squared, we would have to FOIL this b minus x. So we get c squared minus b minus x is equal to a squared minus x squared. Alright, so let's distribute. So we get c squared minus, so b times b is equal to b squared b times negative x is equal to negative bx. Negative x times b is equal to negative bx. And negative x times negative x is equal to positive x squared. And all that is equal to a squared minus x squared. Alright, next we can combine like terms. So both of these are the same term, so we can rewrite it as c squared minus b squared minus 2bx plus x squared. That equals to a squared minus x squared. Now, because we have a negative in front here, we have to distribute it, all of these. So, we get c squared minus b squared plus 2bx minus x squared equals a squared minus x squared. Now this looks pretty chaotic, but it does simplify really nicely. So you notice here that there's 2 negative x squared on both sides. So if you add x squared on both sides, these cancel out. So what you can do is you can rewrite this, super simplify now, c squared minus b squared plus 2bx is equal to a squared. Now, let's just move some of these terms across. We're going to add b squared on both sides, and we're going to subtract 2bx on both sides. And we're going to rewrite it as c squared is equal to a squared plus b squared minus 2bx. So this looks really similar to the original cosine law, but there's something really off about this. There's an x. What's x? Well, here's one of the triangles from here. We're going to take a triangle from here. Since this one has x, we're going to try to figure out what x is in terms of this triangle. So we're going to use the right triangle here, and we're going to see if we can rewrite x as something nicer. So, this is the same triangle as on the right. Let's see which trig function we can use and see if we can isolate for x somehow. Well, as the name suggests, we're probably going to be using the cosine function. So, let's do it. Cosine of c is equal to the adjacent, which is x, over the hypotenuse, which is a. And if we multiply both sides by a, we get a cosine c is equal to x. And since we wanted to get x, we're just going to put this over here. And we're going to get c squared is equal to a squared plus b squared minus 2b a cosine of c. But how your textbook probably writes it, we're just going to swap these two around, and we're going to get our final formula. C squared is equal to a squared plus b squared minus 2ab cosine of c. Make sure this is the capital C. I'll make that really big C. And that, my friends, is the cosine law.